So, hi everybody, my name is Marco. I'm here to talk about the amazing synergy we built between ToffeeX, my company, and Hexagon. As you can tell already from my accent, not British. I am from Rome, from Italy, actually from a very small village close to Rome in the mountain. Very boring village, I would say, something I called my green prison, something from which I wanted to escape, which I did when I moved to London, when I started my PhD at Imperial College. But I'm saying this just to mention, I brought with me one value, which is when there's lots to do, many challenges, many problems to tackle, I resonate more to enable people to solve, to face their challenges rather than solve it directly on my own. Being at Imperial College, obviously, the landscape was sustainability. People working on electrification, people working carbon capture, people working on hydrogen fuel cells, etc. And what does it mean for me, enabling people to do the step forward, to make the jump? It's really, for me, it's creating new design, to enable people to create new design, from new aircraft, new cars, new fuel cells. How is this usually done today? Trial and fail. Humans, designer, try something new, they test it, they fail, and they iterate. But this is expensive, this is slow. Imagine having one software, you click the button, and you get already the best design for a component. And this is what Toffee does. So here, what I'm saying. On the left, you see something that is human design, something made by experience. On the right, the same component, for electrification in this case, designed by Toffee in 1 hour by simulating the physics. This is the best design that does the same job by using 1/3 of the energy. But this is not the full picture. And here is where we introduce Hexagon into the equation. If you have something that is human design, in this case, I brought the example for hydrogen fuel cells. The one on my right is clearly human design. It's made with a certain level of efficiency. It's made to be cheap, to make scalable, to make easy to produce. On the right, we have something, the same component optimized by Toffee. It's way more efficient. It's simulated by the physics. It's driven, the design is driven by the physics, but it's way more expensive to produce. Here is where putting together our software and the software from Hexagon, in particular FTI, for the manufacturability of stamping and the costing of stamping, we reached the perfect trade-off, something that is slightly more expensive, but is critically more efficient. So really, by putting together this, what we are bringing to the customer is the scalability of generative design. The market is huge. Only talking about the market of computer-aided engineering, we are in a market that is more than $2 billion. But we can tackle more horizontal market, like aerospace engineering, overall on the energy transition. We have a great team, bunch of PhD engineers, professors at Imperial College, amazing investors, industrial investors that are fueling our growth. So now I'm here today to say to Hexagon, let's bring this in front of a customer. Only because of this proof of concept, we are already a customer that is ready to adopt this solution. So why stopping here? We did it for stamping. We can do it for milling, so for the automotive sector. So really, let's make the generative design scalable. Thank you very much.